So I'm a postdoc in Joan Heath's lab. What I can potentially do with my background is have a look at a fluorescent zebrafish. So the fluorescence is basically a process where there's a protein within the zebrafish emits light at a particular color. So we can look at multiple different proteins at the same time. We can look at the entire fish as a whole and look at, say, an entire organ. So for example, if we look at this image here, we've got the liver, which is marked in green. Or we can zoom in even further down to a single cell, which is highlighted there in yellow and red. So the yellow and red are two different processes that are occurring within that fish. And when that fish was imaged, it would have been imaged live. So we're looking at what's happening within the live fish in real time. But I can go even further. So with my background and my experience, we can zoom in down to a single particle and see what single particles or single proteins are doing within the live zebrafish. What we're currently pursuing in Joan's lab is to take some of the findings that we've made in the past recent years and look at how particular processes that occur within zebrafish development, particularly looking at the intestine. And when you block these pathways during development, it impairs or disrupts how the intestine develops. And what we're finding is if we actually block these same pathways in a cancer context, you can actually slow down, prevent the growth of cancer, or even potentially kill the cancer off. So what we're currently pursuing is through the WEHI, we've got a chemical library which contains 120,000 compounds. We're testing all 120,000 compounds to see which ones or one or a few compounds are effective against the particular process we're studying. And from there, we'll take the select few compounds that we identify from this drug screen and see how it affects zebrafish development or how this compound behaves within the fish. So things like, is it toxic or is it effective against some of the cancer models? So some of the really preliminary work that we've done looking at this particular process in a cancer context has been carried out in mice, and we've got one zebrafish model. And we're showing if you actually block 50% of this process, we can impair cancer in the lung, in the blood, so lymphoma and leukemia, in the stomach, as well as the liver. So once we have identified and characterized a really effective compound, we'll eventually take this to the clinic with clinicians and other practicing doctors to create a brand new and hopefully very potent anti-cancer therapy. So what we actually hope is that by identifying a pathway within the zebrafish development, we can translate this to a novel and powerful anti-cancer therapy, which will hopefully save thousands of lives.